Good day, friends. We will be continuing with our discussion or our presentation on number lines. So number lines or number system, and especially we will be now concentrating more on irrational numbers and rational numbers. So let me go a little back and continue what we have learned in our previous video. So we talked about is natural numbers, and that is being designated as n. Then we went for whole numbers, and that is designated by w. We added negative numbers and we called it integers, and that is designated as z. Then we added fractions, including in that, and that we designated as q. Okay, so altogether this we call it rational numbers. Okay, and we said what are rational number? It came out of these, and we said that the rational number is to be presented by a fraction, okay, which is p by q, and where q is not equal to 0. This I just repeated just to do it. Now we have also found, that there are some numbers which you cannot represent in this form, and that we call it, so not represented as p by q. Okay, not. So this we call it irrational number. Irrational numbers. Okay, altogether, the whole gamut of the whole thing altogether, we call it real numbers. And that is represented as R. So all these N, W, Z, Q, they all became a member of R. Okay. Now how do I know between a rational and an irrational number? So for this, one of the way is already, as I have said, that they are well known, well established icons of rational number that you have been using. One is definitely pi, that is equal to relates to a circle, and what is that relates to? That is the circumference 2 pi r, I will say pi d, that helps me. Oh, what is the circumference? Circumference of a circle, nothing but its perimeter. In one case we call it, other figures we call it perimeters, and in case of circle we call it circumference. Okay, we call it circumference. So that is the outside area. So that would be, if this is the diameter, then it would be pi d. And then if I take the ratio of circle, that means I take the ratio of circumference divided by this is circumference divided by diameter, so that is d, so I will end up getting it pi. So you can measure the circumference and then you can also measure the diameter, and you will end up getting pi. But this pi never can be written as P by Q. Not as this, cannot be written as this. Because it continues longer. So this is 1 is pi, other is root 2, then we have E, and we have also golden rule. Okay, we have all these, they are irrational number. Irrational numbers. Okay, so we know, you will learn, you have already learned about this, the golden rule, and this is called Euler's number. This is called Euler's number. And this you will learn into higher classes. So I am not going to continue it here. So one of the way of distinguishing between a rational and irrational number is called decimal expansion. Decimal expansion. What does it mean? Function. So what you do, you take a fraction. So let us talk about fractions. This type of fractions we will take 10 by 3, let us say 7 by 8, and let us say 1 by 7. Okay, we'll talk about these three fractions. And then we'll be able to understand what is meant by these decimal expansions. Now these are in the form of P by Q, right? Because the top is P and next is Q. Okay, let us see how far they hold good for each one of them. Okay, if I divide 10 by 3, what do I get? This will be 9, 1, 0. So I will put 0.910. So you will see this 1 is coming. This 1 is being repeated. Again 9. So again 1, 0. So same thing is coming. So these will continue repeating. So these 3 repeats. So this is, remember, division is 3 and one number is repeating. So its remainder in each cases. Remainder in each cases would be 1, 1 and 1. So this we know. This is 1. 10 by 3. What about 7 by 8? So 8 and this is 7. Okay. So first it doesn't go. Put a point. 70. So what do I get? 8 into 8, 64. So I get 60. Okay. Point. Then what I get? 7. That is 56. Then I get 4 and I put 0. Then 8 into 5. Oh, this 8 doesn't look very handsome. So I will change it. 8 into 5 is 40. So it terminates here. It doesn't. This doesn't. So remainder is 0. So it gets fixed here. 7 by 8. What about 1 by 7? So 7 here, 1 here. So point, because it will not go. So 0, I will put 7 here, 30. So I think it will take a lot of space. So I will do it on top of here, because then it will, I know it is going to come on top of it here. So I will move it on this directions to here. So this I will move it up. So this will be 7 by 1, 7. Here it is 1.017. So it will be 34 it will be 28, 20. Well, how much it will go? It will go 2, so it will be 14. Again it is 60, so again 8, 56. Again it becomes 40. Okay, so 40 it will go to 5. So this will be 35, and again I will go from here to here. Okay, so that becomes 50, and I will become 7. So this is 49. Again 1. So this 1, what I started with, this is 1 upon 7. This 1 has come back. So again it will go through the same cycle. So it will, which means again I will put, again it will be 1, 4, 2, 8, 5, 7. It will keep on continuing. Again 1, 4, 2, 8, 5, 7. If you continue doing it. So like this, this is this is 3, 3, 3. In this case, this whole thing is repeating. So this is repeating, or it is also called recurring. Keeps on happening all the way through. So in one cases there is a specific, so this we can call it terminating. That means terminating means reminder, or not reminder, remainder. Remainder is equal to 0. In this case, the remainder keeps on happening. Here also this is repeating. This is also repeating, and this is also called recurring. So I will use another one. Recurring. So these fractions, which are, even though they do not terminate, they do not terminate. That means this one, let's call it A, let us call this one B, and this is called C. Let's call these 3. So these 3, they are terminating. This one, C, is terminating, but these are non-terminating, repeating, recurring, and this is also recurring, repeating and recurring. Okay, I can show it to you that there are certain other this thing which will keep on going on. Like still today, pi has not ended and pi has kept on going, which are will give you a non-recurring. So there will be certain things which are non-recurring. For example, pi, the number 3.1459, and it keeps on doing it. And there is not a block, like we have a block here, that keeps on repeating. Here we have a block, here we have got a block of 3, which keeps on repeating. So in this pi, this is non-repeating. So when you have, first of all, A, so what are the points that we have to do? We will remember this, right? I will write somewhere, I will not erase this block and I will not erase this block. This block is finalized, so I have got nothing to do with it right now. I need not have to recollect it, so I will erase it. Okay, now let us see what are the points that we need to understand. So I will just write down those points here. Point number 1, A fraction. We are talking about a fraction. Fraction 1, it could be terminating. Terminating. Terminating, which one we worked with? We worked with 7 by 8. Right? Second one is, this is non-terminating. Non-terminating. Non-terminating, but the number of, I will not write number, but the digits in quotient, digits in quotient is repeating. Okay, this is repeating. Okay, in case of other one, as I have said, this is will be this will be non-terminating. So this much is this thing. This is non-terminating. And non-repeating. And non-repeating. So it will not repeat. Non-terminating, non-repeating digits in the quotient. So does it make sense? So these are the decimal expansions. These are decimal expansions. Okay, these are the decimal expansions if you see, and so this is non-terminating, non-repeating, okay, and digit in the quotient. So this will be, this one, if you see this would be irrational number. Okay, there is another thing which is important, that in case of repeating, you give it a bar. So in case of this you have understood this. So there are cases. So what would be the cases? One case is very easy. One case is what it terminates like 7 by 8. We have no problems. I mean, this is straightforward. And what are the advantage? What is the advantage of this kind of rational numbers? This kind of rational number? Because they are in the form of PQ, that is P is equal to 7, Q equal to 8. It has to be in this form because to be a fraction, this 8 should be greater. So here denominator should be greater than numerator. That's why you get a fraction. Okay, this is terminating, which means this is definitive. That means I can multiply both by 2, or I can take a tape and take 7 measures here, and another I can take another length which measures 8, and there will be definitive. The question of any kind of error will not come in there. Okay, so we go through the same exercises again. This one, 1 by 7, where the decimal expansion repeats, that is 0.142857, you put a bar on top of it. Okay, now 10 by 3, that is also repeating, is 3, 3, 3. So I will put a bar on top of 3 because this is the only digit that is repeating. Here you have got 1, 2, 3, 4, 5, 6. So many digits are repeating. So this is over. So we can do one thing. We can take one of these and show you how they can convert it into a PQ, P by Q system, and they can be called a national number. Before going through this, there are two questions which are remaining from our earlier, I think 1.3. I think I would like to complete them so that there is a completeness and we will be able to do those. So where it says that this is exercise 1.1, you little bit come out of rational and irrational numbers because you may be getting bored. So I thought I will do this one again. So this was question number 3. Question number 3, exercise 1.1 of again NCERT book, class, I will use now the Roman, so class 9. Okay, so the question number says find 5 rational number between 3 by 5 and 4 by 5. Last time I showed you one method by taking this 5 common. There is another method which is as per this book, and I think that is also very nice. So you multiply whenever you see the fraction. Whenever you see a fraction which are definitive fractions, and you can see that decimal remainders will terminate. So you see a 5 by 3 will be what? 0.6. Okay, 4 by 5 will be what? Will be 0.8. Right? So these are definitive. So this is rational number. So there is no problem on these issues. We have checked it. Okay? We checked it and we are doing it. So what you have to do when you have got a fraction, this thing, multiply both the denominator and the numerator by 10. So this is 30 by 50 and this one will be 40 by 50. And it says what? 5 rational number. So you can go by 31 by 50, then you can go 33 by 50, you can go 35 by 50, or you can go 37 by 50, and you can go 39 by 50. So you can also use 34 by 50 here, you can do all these things, but I thought it shows. Now many cases what happens, this will be 7 by 10. Okay, so whenever you give a fraction, this is another important point to know. Whenever a fraction is represented it should be in its co-prime number. Means what? You see, 1.5 I can also write 4 by 8. I can also write, say, 27 by 54. If you see, this becomes half, this also become half. But generally for in a number line or any this kind of a night line, you should always remember that this 1.5 will only be recognized. So here when I write 35 by 50, I should convert it, I should see whether they can be any one of them can be converted into the co-prime number, and I should convert them into their co-prime number. This one can be converted, so I have converted, and this will be see in any book, any answer. If you see the answer, you will see it has been converted by 7 by 10, and you should not get confused why it is being shown like that. Is my result correct? Okay, so this is necessary, especially when we were talking about rational and irrational number. So this is different. These are all rational number. So they have already mentioned here this thing. So question number 3 is complete. Okay. Now let us come to question number 4. Question number 4 is of 3 parts. Okay. This is question number now is 4. So one is 1. Is every natural number is a whole number? Yes. Why? Because natural numbers is a part of a whole number. Because when you add 0, these natural numbers becomes whole numbers. Number 2, the question is what? Is every integer is a whole number? What does integer means? Which one is integer? What do we call integer? Integer is come when we add to the whole number negative numbers. When we add negative numbers to whole number. Right? So how can an integer become a whole number? So this one is false. Because integer whole number के अंदर आता ही नहीं है. Whole number के बाद जब हम negative numbers add करते हैं, then that set becomes a whole, becomes we call those belonging with this thing as in the class of integers. So this is false. Okay. Now number 3rd. I think I can continue with this thing. Okay. 3rd is 1, 2, 3 is every national number, rational number every national number is a whole number. No, how can it be? Because in rational number you also have fractions. You have fractions. So integers plus fraction gives you rational numbers. The whole numbers does not contain your fractions. So this will be also be false. So I think we have completed exercise number 1.1. If any one of you have a problem, you will find that in my phone number is given. You can call me and you can discuss, or you can also send me an email. Or my number is also in WhatsApp, so you can give me a message in the WhatsApp. I will look into it and I will definitely answer. Okay, so this exercise is over and this completes us our this thing. So now we will go to exercise 1, then we will go to exercise 1, see how much we have covered until this. So we will go to exercise number 1.2. Okay, first of all, I think we have covered most of it, and whatever is remaining I will get it done. So this would be exercise 1.2, and in case of it says first, this can come into your MCQs, so I thought this must be covered. It says, is every true and false? So true and false statements. Every irrational number, irrational, my relation with them. Irrational number. Irrational number is a real number. So it is true, because real number also contains irrational number. So every irrational number will be a part of the real number, because you remember we stopped at real number. We said all these things, whole gamut belongs to real number. Okay. Number 2, every point on the number line, number line is of the form root m, where m is a natural number. I am writing the whole thing so that you understand how this thing. No, every point, how can this be? How can this be? Because in the number line, so remember this is a clue. In the number line you have all numbers. That means you have got negative numbers which converted into integers. You have fractions, 1.5. So root m, this is not possible. We have not been considered negative numbers. We are not considered negative numbers. So we have not yet considered any number -2. There is another realm of numbers which are known as imaginary numbers. We are not going into that. So we are only going into this thing. So every point on the number line as of now, this is not true, so this should be false. F-A-L-A-C. Okay, so this is true, number 2 is false. Okay, let's go to number 3. Number 3 is what? Number 3 is what? Number 3 is every real number is an irrational number. Every real number is an irrational number. How would you take it? Number 3, every real number is an irrational number? No, it is false. Why? There are other numbers in the real number domain. There are many other numbers in the real number domain. There are rational numbers, there are integers, there are whole numbers. So you cannot say that every rational number. You cannot say every rational number is an irrational number. So question number, question number of exercise 1.2 is we have completed. So, okay. You have to read the question a number of times. Think about it. Don't just memorize and say this is true and that is false and all that. See what it is saying. So every word in that question will have a meaning. So again, question number 2, it says, are the square roots is written like this, square roots of all positive integers. Are irrational? Are positive roots of are no? Why? Root of 4 is equal to 2, and this is actually a whole number. So it cannot be irrational. Okay. So question number 1, question number 2 is taken care of. Question number 3 we have already done it. Question number 3 we have done it. It says so can be represented on a number line. So we have done it. We have said that you take a number line, you take 2 units. Say this is 1 and this is 2, and similarly you draw a perpendicular line here and that goes to 1 unit. Okay, this is 1 unit. And then you join these two. Since I have drawn a perpendicular line, so this is, I can apply Pythagoras theorem, and this is 1, this is 1, and this is 1. This whole thing is equal to 2. So let us say O, A and B. So this would be equal to, OB will be, OB square would be equal to 2 square plus 1 square, that is equal to 4 plus 1, that is equal to 5. Therefore OB is equal to root of 5. So I have got root of 5. So this is the length of root of 5. I'll take it and put it on the number line. So question number 3 is over. And then again the total spiral, 4 classroom activity, this is the thing. We have gone through that. So I will say question number, this one, 1.5 is over. Now let us see how we can convert so that it says Okay, here there is some examples are given. That is example number 6. I think we need to go through that so that we can get a handle on whatever we have been doing so long. So it says that how to show something as a rational number. Okay, there is a number which has been given along with its decimal expansion. It says show that this is example number 6. Number 6, and this says show that that 3.142678 is a rational number. Okay, how do I do it? It's very simple. What do? We write 3142678 divided by 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so is a rational number. Why? Because this has been shown in terms of P by Q, and where Q is not equal to 0. This is not 0. So that this is a rational number. This number with this thing is a rational number. Okay. So again says that so that expansion, decimal expansion that we have done out of 1/3, that says so 0.333 and 3. How do I write it down, this one? 0. How do I write it down? I can easily shorthand it by write 3.3 on the bar. Whatever on the bar, it is recurring. So this is easiest way this is done, that you take this is equal to x. So x equal to 0.33, another 3 you take, 3 3s. Okay. Now since this is 1 is recurring, okay, so what I do, I multiply both sides by 10. So what do I get? In this side I get 10x on the left hand side. This side I get 3.33 because this is multiplied. I can write 3.33 this one as 3.0 plus 0.33. So this can be written like that. I think everybody agrees. Okay, so I can write this one as also, because I have taken this one, I should write like this. Okay, so let me take this one so that there is a consistency in between. So this is 3.0, not 30. This is 3.0. Okay, now this is 3, and so I can write, again the x has come. So I can write 3.0. This one I will written as x, because this is how x has been taken. So plus x. So take this x here. So this is 10x minus x is equal to 3.0. Therefore 9x is equal to 3.0, or x is equal to 3.0 divided by 9, that is 1/3. So you see this recurring, which one is recurring, I can convert in the form of PQ. So that is what it says. can be expressed so that it can be expressed in the form of PQ. So this is in the form P by Q, where Q is not equal to 0. Hence this part of it is a rational number. So anyone, so 10 by 3, where this 3.3 came out, 3.333, that is came out recurring. So that is not an irrational number, not irrational, because first of all it is repeating, and it is also not different numbers are not there. Okay, this is repeating, and even though it is not terminating, but it is repeating of the numbers. Okay, so that takes care of this. Okay, now next example 8. So we did example 6 we have done. This is example 7. This is not 6 is over. So this was example 7. Now we will be doing example 8. What is that example 8 says? What does example 8 says? Example 8 says, so I will erase this. Okay, so we will now go to example. This is again comes out with a repeating 1 point. Again show that. Okay, let me write down this thing. It's only show that 1.272727. So this is not terminating. This is going on. This is not terminating, but this is repeating. This is 2727. This is repeating. So how do I write it? This is 1.27 on the bar. This last time it was only 1 which is repeating. This time it is 2 is repeating. So what do I do? Again follow the same procedure. What is that procedure? First of all, you put x equal to 0.27. 0.27, and you can put 27 and 27. Let us write the whatever is been given. I can go further, but let's do it this way. Okay. Now multiply on both sides by 100, because 2 is repeating. Number 2, 2 digits are repeating. 2 digits are repeating. So this time, since there are 2 digits, I will it has multiplied by 100. So this would be equal to, if I multiply it by this is 27.2727, right? So what I can do? I can write it like this. So this will be 1.27. So x will be taking as x equal to 1.27, the whole thing. I have to take the whole thing. So not with the 0, but it should be 1 point. I don't know why I missed it that. So this should be 1 point. Okay, we have to take, now here last time we took x equal to for 1 repeating, that means 0.33, we took x equal to 0.3 because that shifted here. This time I have to take x equal to whole thing. So this time x should be equal to this time x should be equal to the total one you take, 1.27. Okay, and you go to 27. This is your x equal to. Okay, now you multiply it by 100 on both sides. 100x is equal to 127.27. 1.27. Okay, so this I can write it as 126 plus 1.27. Okay, right? So this is occurring. So I have, okay, I will take it as 1.27 into 1.27. So this would be 126 plus x. Is that okay with you? Or since I can take another 27 here, because it says 127, 27, so 3 times. Let me also take it 3 times so that it is completeness is there. So this would be equal to 27. Okay, because here also it should come 3 times. Okay, so it will be 1.2727. This is recurring, so no use of writing further. So I can take this one as x. So this would be 100x minus x is equal to 126. Therefore 99x is equal to 126. So x is equal to 126 by 99. So this is also in the form P by Q. So let me recapitulate, say 1 that you take, when you are taking the x, you take the whole thing. You do not take after 0.033 as we have done in case of 1 by 3. No, because there was only 1 repeating. When it is repeating twice, you take the whole thing as x and then you continue like this, and this is what it will be showing in the book also. Now 126 by 99, I cannot leave it like this. Why? Because you see it can be reduced to its coprime. This will be 9 if you do this, it will be 11, and this will be 14. So this will be 14 by 11. So I have to leave it like this. But this is now a rational number, even though decimal expansion of it is non-terminating, but it is repeating. So this is the importance of these questions. Now, here we have done that, okay? There is another question. Here the 1 is not there, so you have to be careful what you have to do. Here it doesn't say. In the previous one, it used to say so that 1 point, it was said so that this. This time, next time, the next question, that is question number 9, it's a little bit different. I mean example number 9, and it is little bit different. Here, this one, mantissa will not be there. So mantissa will not be there, and here 0, show that again, show that. So that 0.23535. 0.53535. So what is repeating here? Here it is repeating 3535 is repeating. So what I can write? I can write so that okay, I went further than that. Let me complete this. So that this is equal to 0.235 on the bar. Okay, 0.235 is again the same question. Can be, okay, it is given little bit different. Instead of saying it's a rational number, it says can be shown. There is no difference. Don't get again confused by the wording, so I am writing them that can be shown in the form P by Q. So there is nothing by saying that show that it is a rational number. Okay, instead of showing that it is that, where again is the form PQ, where again this will be where P and Q are integers and Q is not equal to 0. This is a standard form. So that goes, one looks so big, it's different. Nothing is different. It is only saying this thing. Can be shown in this form, right? So let's do this. So let us again, since this is like this, take the whole thing. There is nothing here. Okay? In this expansion of decimal form. Only it says that 2 digits are repeating. Okay? 2 digits are repeating. This and these 2 digits are repeating. So there is a bar on top of it. So again do the same process. Here you say 0.235. Okay? Let us take x. Since 2 is repeating, again 100x is equal to, it will be, if I multiply it is 23.5. Okay, so what I can do, I can okay, now here you have to be a little bit careful. What you have to do, 23 point, again I have to get this, so it should be 23.3 plus 0.235, right? 0.235, okay? 0.235 we can take it from there. 0.235. So I have taken 0.235 out of this and I have converted this 5 into 3. Okay, so that I can deduct this one. What does it give? This gives me 23.3, and this now I can write x. So again this would be 100x minus x is equal to 23.3. Therefore 99x is equal to 23.3. Therefore x equal to 23.3 by 99. Okay, let's see whether we have done it. 23 by 9, we have done it. Now I should not leave it here like this. So this would be written as x equal to 23.3 by 990. Is it okay? ठीक है viewers, thank you very much in having the patience in going through the whole part of this video. This video, as you know, has been will be subsequently a number of videos will be there in order to cover each part of the subject. I am sure you have already liked the video as well as you have subscribed the channel. So have a good day and with all my blessings. Thank you.